Salisbury Hill, I could see the city light. Wind was blowing, time stood still. Eagle flew out of the night. He was something to observe. Came in close.
All right, hello there. Today I'm going to be showing you guys about systems of inequalities. The first day of it. This is a bigger topic. It's going to take me a couple days to get through it all. So we're just going to start with the first day. So a system of inequalities is when you have more than one, right? We did systems of equations where, when we graphed them, you put two lines on the same graph and then you looked for the point of intersection. This is a little different because it's an inequality, so there's more than one thing that is a solution. Just like if I said, x is greater than 5, there's a whole bunch of different answers there that are bigger than 5. And just like that, when I'm graphing the linear inequalities, there's going to be more than one solution to that. And I'll get to that shortly. So the first thing is I'm going to graph these two, and I'm going to really treat it like an equal sign at first, okay? The first main difference is if I have just one of those, just greater than or less than, when I graph it, that's what's going to be a dashed line, okay? And if it's got the line underneath it, if it's greater than or equal to or less than or equal to, that will be a solid line, okay? And I'll get to those in a minute or two. So I'm going to graph the first one first, the y is greater than 2x minus 1. Now, a quick reminder that, the slope of that line is -2, and you can always make a whole number into a fraction by putting it over 1. And the y-intercept is -1, and I got the y-intercept from that -1 there. So that's the y-intercept, and the slope is in front of the x. Okay. All right, so I'm going to graph that. Start at -1, and then my rise over run is 2 over 1, and it's negative. Why did I write negative there? That should have been positive. Put your notes there. Positive 2 over 1, so I'm going to go up 2 and right 1. Up 2 and right 1, and you can always make that little triangle there if you forget. So there's my slope. Now this is going to be a dashed line, which means it's not going to be solid, but it's going to have some space in there. Okay, and that's going to be my line. Now, the other thing I'm going to do is I'm going to come to the shading part afterwards, okay? Let me graph the other one. And we already did this in the last section. Y is less than or equal to -x plus 1, which means I'm going to make that one green. The slope of that line is what's in front of the x. And remember, there's always an implied 1 there if there's nothing written. So that's -1 over 1. And the y-intercept of this line is +1. And I'm getting that here from the +1. All right, so when I graph this, I'm going to start at the y-intercept, which is +1. And then it's got a slope of -1, which is up 1 over 1, up 1 over 1, up to the left. Okay, now this will be a solid line because it's got that or equal to underneath it. Okay, and that's that line. All right. So I've got the lines, and those are called the boundary lines. Now there's a couple ways you can do this. If you remember from before, my preferential way is, if it's y is greater than, you shade above the line. It could also be y is greater than or equal to. And if it was the other way, y is less than, or y is less than or equal to, you shade below the line. So if I go up to the red line first, since that one is y is greater than, I'm going to be shading above it. So there's a couple ways you could do this. I'll show you both. Red line above the red line, which means all of this side will get shaded. And the green one is y is less than or equal to, which means I'll shade below the line. Let me get green. And if I was shading below it, that would be this side. Okay, which means that the solution area is where it's double shaded, okay? And that's one way you can do it. Now I'm going to erase this here so you can see that that would be what's left. When you're doing it your way, you certainly could leave it, but now that's one way to do it. You could also pick some test points and throw those in there. You could pick one side of the line and plug it in. I love using 0, 0. I'm not sure this is the best one to use 0, 0 for because that's really close to that line there. You can also do it with test points that way. I might use, 1, 1 is pretty good in this case. That's another nice easy one. If I was to plug in 1, 1, I get, for the top equation, 1 is greater than the 2x minus 1, 1 is greater than 1. 1's not greater than 1, which means it's the other side of that line. So that would have been, that's a good one for the green line. Not such a good one for the red line because it's right on the red line. So if I use a different test point for the red one, maybe I'll use 2, 2 for the red line. That's clearly below it. If I plug in 2, 2, you get 2 is less than or equal to negative 2 plus 1, which means 2 is greater than or equal to negative 1, and that would be less, false, which means it would be the other side of the red line. So you could do it that way, not necessarily the way I like to do it. But that's one way to do it with the double shading. The next one, I'm going to show you a slightly different way to do it. The second one, I got y is greater than x, and the second equation, I've got y is less than or equal to negative 1/3 x minus 1. Okay, so I'm going to go and graph this first. Remember, with that top equation, or inequality, excuse me, there's no y-intercept, so you can always put a plus 0 after that, and then my y-intercept is 0. My slope is what's in front of the x, which there's an implied 1 there, so that's 1 over 1. Okay, so I'm going to start at 0. Is that going to be a dashed line or solid line? That would be dashed line. That's the thing I always make a mistake on. Make them all solid by accident. All right, so slope is up 1 over 1, up 1 over 1, up 1 over 1, and we said that's a dashed line. So all right, so there's the first one. Second one has slope of negative 1/3 and a y-intercept of negative 1. So I can go over here to the negative 1, start there, and then this one's got slope of negative 1. Which means I'm going to go up and to the left and down and to the right, and that one's a solid line because it's got that or equals 2 underneath it. Okay. Oops, wait. Did I do a slope? I did a slope of 1. I made a mistake there. Sorry about that. So the y-intercept was good, but I'm going to go up 1, left 3. 2, 3. 1, 3. Okay, now make. Okay. Now this is the second way I like to do these. With the shading part. So if I get to the red line here, this is y is greater than, so that would be shading above it. I'm going to use some arrows this time. And the second one is y, green line, is y is less than or equal to. So that means I shade below the line. So I'm going to put arrows from the green line going down below it. And then the solution area is going to be where those two, where all the arrows are pointing at each other, which would be this area here. Okay? See that the arrows are pointing at each other that way. And that's another way you can do it as well. You can leave the arrows if you like or erase them. It doesn't really bother me either way. Okay? If you got questions on that, please bring it to class. All right, I'm on number 3 now. That was number 2. This was number 1. Let's do a you try. Why don't you try this one? Number 3. Your inequalities are going to be y is greater than 3x minus 2, and y is less than negative 1/2 x minus 1. And you try this one. And come back and check your answers. Okay, welcome back. All right, so first one has a y-intercept of negative 2, slope of 3. So that would be y-intercept of negative 2. It's here. And slope of 3 would be 3 over 1, so that's up 3. 1, 2, 3, right 1. 1, 2, 3, right 1. Solid line or dashed line? Dashed line. They're both going to be dashed lines. Second one has a slope of, do this with blue, slope's negative 1/2. Y-intercept of negative 1. Y-intercept negative 1, slope of negative 1/2, so that's up 1, rises 1, run is 2. 1 over 2, also a dashed line. Okay, so I got the boundary lines. Now let's talk about which side to shade. This is the part that students struggle with the most. Which part to shade? You know, this is the challenging part. So if you get this part, you're really pretty good, because I know you guys all learned how to graph these lines already. We already did that a couple of chapters ago. All right, so the top one, y is greater than, that's the red line. So if it's y is greater than, I'm going to shade above the line, which is that way. I'm going to do the arrow technique this time. And if I'm shading the blue line, that's y is less than, so that'll be below the line. And then shade the area that where all the arrows are pointing at each other. That would be here. Okay. So that means any point inside of this area here in that, that quarter of the graph would be a solution. Any one of them. There's an infinite number of points in that area, therefore there's an infinite number of solutions. Okay. All right. All right, here's my last one. Number 4, negative 3y plus x is less than negative 9. Wait, make that negative 7. And x, oops, that was supposed to be negative 9, sorry. X is greater than negative 2. Okay, those are the two equations we're working with, or two inequalities, I should say. Now, the first one, actually move this one. The first one, it's there's a couple ways you could do this. I think what I would tend to do is manipulate it so I get y alone. All right, these are much easier if it's y equals mx plus b or y is less than mx plus b, which means I'd like to get the y alone. So if I subtract x from both sides, I get negative 3y is less than, I'm going to put the negative x first. You can do that as long as I keep the signs correct. All right, so I got negative 3y is less than negative x minus 9. All right, now I need to get that y alone, which means there's multiplication connecting the negative 3 and the y, so I'm going to divide everything by negative 3. Now, it's been a long time since we did this, but hopefully you remember that if I divide both sides of an inequality by a negative number, I have to flip the arrow the other direction. All right, if it's got that line underneath it for or equals 2, you keep it there. If it doesn't have it there, just don't add it. All right, so negative divided by negative is positive. This is 1x, which means 1 divided by 3 is 1 over 3. Negative 9 divided by negative 3 is plus 3. So that's the one I'm going to be graphing now. All right, a little bit of manipulation there, make my life much easier. All right, so I'm going to start with that purple line. That's got a y-intercept of +3, which is here. And then a slope of 1/3. Positive slope goes that way, up and to the right. So I'm going to go up 1/3. You can also go down 1, left 3, if you prefer. That's going to be a dashed line, because it doesn't have the line underneath it. So that looks like that. Now the blue one, these are the easy hard ones. They're easy because it's either vertical or horizontal, but students often forget which it is. This one happens to be vertical. It's going through -2 on the x-axis, and once again it is a dashed line. All right, now let's start with that one, the blue. This is pretty easy. We're on the x-axis. Which numbers are greater than -2? Well, 2 is greater than -2. 4 is greater than -2, and those are all on the right side of that line. So therefore, that's the side I'm going to shade here. I think I'll just do it with arrows here. Back to the purple line. Its y is greater than -1/3, so I'm shading above this line, which means where is the area where both arrows are all pointing at each other? That would be this area. So that whole section is your solution, going all the way up to that blue line. Okay, and that is my last problem for today, and we'll pick up there. Next video, I'll show you some more. Have a great night. See you all tomorrow. Here is more Peter Gabriel to take it home.
Standing, stretching every nerve. I had to listen, had no choice. I did not believe the information. Just had to trust imagination. My heart